Students. Now let's talk about another important topic, that's average speed and average velocity. Till now we only talk about speed and velocity. Now let's see what's average speed. Now we will try to understand the significance of the term average. So when you have this word average before speed and velocity, how does it make a difference? So let's try to see what's average speed as such. Average speed is a measure of distance covered, total distance covered in a given time. So normally how do we define speed? The distance covered divided by time taken. So when I say average speed, I am saying it is the total distance covered divided by time taken. Do you see much difference in the definition? It's not any significant difference as such. But you will try to understand the difference once I take an example. Now I will take two examples, one of uniform motion and another of non-uniform motion. Because when I consider example of non-uniform motion, that is where you will understand the difference between average speed and speed at its best. Let's first take the simpler one, that is of uniform motion. Suppose this is a car which is covering equal distances in equal time intervals. And let's suppose this car covers 20 kilometers in 1 hour. It starts from point A, moves to point B, and the distance between A and B is 20 kilometers. And this car covered this distance in 1 hour. So, what would be the speed, average speed of this car? So average speed of the car during its journey will be total distance covered divided by total time taken. That is 20 kilometer divided by 1 hour, and the average speed will come out 20 kilometers per hour. Now if I say what is the speed of this car, the speed of this car is same as the average speed of car. In this car, because the car is traveling equal distances in equal intervals of time. That means in every 1 hour, it's covering some 20 kilometers. So because it's moving in uniform motion, therefore we can say that speed is nothing but it's same as average speed here. Now in this case, if we plot a graph for uniform motion, it will come like a straight line, right? Because in uniform motion we have a straight line. Now let's look at the example for non-uniform motion. What happens in non-uniform motion? The speed of vehicle varies, like initially, say the speed of a vehicle is less, then the speed of vehicle increases little bit, and then the speed of vehicle increases a lot. So that means speed of vehicle is changing from one point to another. So if I say the vehicle starts moving from point A to say point B. Now in this entire journey, what's the average speed of the vehicle? So whenever we talk of average speed, that is the average speed for an entire journey. Now in that journey, maybe the speed was different during different points of time. So in this case also, you can say that when I say the average speed for the entire journey, when I say the average speed for the entire journey, how would I calculate that? The total distance covered divided by total time taken, right? Now let us suppose distance between this point A and point B is 20 kilometers, and time it took to reach from A to B is 1 hour. So average speed would come out again 20 kilometer per hour. So this is my average speed for the entire journey. But now at different instance of time, this vehicle has different velocities. For example, when the vehicle was at the position, say, when it was crowded by the other two vehicles, so it had a lesser speed. Maybe the speed of vehicle at this point is say 5 kilometer per hour. Now, then it moved a little bit. Maybe its speed increases a bit, and say it became 7 kilometer per hour. Then again, say it reaches to smooth road and speed increases to some higher value, say 25 kilometer per hour. So what I am trying to say is that during the entire journey, sometimes speed of vehicle is more and sometimes it was less. That means it was not uniform every time. Initially, it was covering less distance for same interval of time, but later it was covering more distance for the same interval of time. That means the speed of vehicle at every instant of time was different. But when I talk of average speed, I'm talking about the average speed for the entire journey. Now, when I say average speed is 20 kilometers per hour, that means I don't know what was the speed at every instant of time. Maybe that was different. But if the vehicle have traveled uniformly, that if it would have covered equal distances in equal intervals of time, in that case, it would have covered 20 kilometers in 1 hour, every 1 hour. So now you understood the significance of average speed. Average speed tells us the speed or the average speed for the entire journey. Maybe the vehicle has different speeds at different instants of time, but the average speed for the whole journey is given by the total distance covered divided by total time taken. Sometimes people do these kind of mistakes, like let's suppose there is a car and it starts from say point A and it goes to point B and then goes to point C. Now when car goes from A to B, average speed of car was 5 kilometer per hour, and when it goes from B to C, average speed of car was 6 kilometer per hour. Now, what is the average speed for the entire journey when it goes from A to C? So sometimes people think that average speed from A to C is 5 plus 6, and you will get 11 kilometer per hour. But that is not the case. Whenever you want to calculate the entire speed here, you should always calculate the total distance, then you should divide it by total time taken. So in this case, total distance AC divided by the total time taken. So this is the correct way, okay? Now let's talk about average and instantaneous speed. Now you understood why we need two different analogies for speed. One is average speed and other is instantaneous speed. Because in case of non-uniform motion, your speed keeps changing with every instant of time. So average speed is the measure of total distance covered in a given time, and instantaneous speed is the measure of distance covered at every instant of time. Now, on similar lines, we have an velocity. The way we defined average speed, similarly we define an average velocity. The only difference is that in case of speed, we are talking about the distance covered, and in case of velocity, we talk about the displacement. That is, we also talk about the direction here, okay? Let's take the same example again. A car which travels from A to B travels 10 kilometer in the east direction in 2 hours. So irrespective of whether the velocity increases or decreases in between the journey. Now what would be the average velocity for the entire journey? It would be the total displacement divided by total time taken, right? So 10 divided by 2 and you will get 5 kilometer per hour, right? In the east direction. So this is my velocity here. So velocity will have direction associated to it. Velocity is related to displacement. This is for the uniform case. Now let's look at, for example, say a car moves from A to B and then comes from again back from B to A. What is the total displacement in this case? So in this case, total displacement is 0 because the starting and the end points are the same. So therefore, in this case, the average velocity for the entire journey, for the journey comes out to be 0. It's similar to average speed. Okay. Now I hope you understood why we have this average and instantaneous things separately for speed and velocity. Because speed and velocity, they keep changing in case of non-uniform motion. And most of the motion which we see around us are all non-uniform motions. Depending upon the situation, your speed and velocity keep on changing. That's where you have two different terms, average and instantaneous. Now on similar lines, we talk about average and instantaneous velocity. Average velocity for the total journey. Average velocity means the measure of total displacement covered by time. And instantaneous velocity is the measure of displacement covered at every instant of time. Thank you.